Good morning, students. The last class we discussed about electromagnetic spectrum. In electromagnetic spectrum, we have studied about continuous, in electromagnetic spectrum we have studied about continuous spectrum. Now we are going to study about another spectrum, that is atomic spectrum. The atomic spectrum is nothing but a range of characteristics in frequency. In electromagnetic radiations, we already told that gamma rays, X-rays, UV, visible, infrared, and radio waves. If increasing the wavelength, decreases in frequency. Correct, no? Similarly, the range of characteristics frequency of electromagnetic radiations that are ready to absorb or emit by an atom means the atom is there. Atom is ready to absorb the radiation and also emitted the radiation. Is nothing but atomic spectrum. We will write the definition. Range of characteristics frequency of electromagnetic radiation that are readily observed and emitted by an atom is nothing but atomic spectrum. Means atomic spectrum, the atom is ready to absorb or emitted by electromagnetic radiation frequencies, based on electromagnetic radiation frequencies. Okay, next we are going to study about atomic emission spectrum. Okay, atomic emission spectrum. Atomic emission spectrum, or line spectrum, means line spectrum. By the heading only will tell atoms will be emitting the spectrum in the form of which lines. Okay, you see the spectrum, the definition for atomic emission spectrum means that it emits in the form of lines. The spectrum in which line represents a specific wavelength or wavelength radiation which is emitted by an atom is referred as a line spectrum. You see, when the atom will be absorb the radiations and emitting in the form of line is nothing but a line spectrum in specific wavelength or specific wave radiations. For example, you take sodium in we take Bunsen burner, for example. Bunsen burner, the sodium, if we use, it shows the yellow color. If we use strontium, it shows red color. If we use similarly potassium, it shows violet. Means it shows like lines. For example, we are taking first sodium. No? Sodium, it shows the lines like this. If you go to potassium, the lines shown like this. If you go to similarly for hydrogen, okay, it shows different lines. It will be in 3500. If you take hydrogen, it shows the lines banded series like 7500 nanometers to 3500 nanometers. This is the line spectrum. The atomic spectrum is nothing but the range of the characteristic frequency of electromagnetic radiation that are readily absorbed or emitted by the atom is nothing but atomic spectrum. What is atomic emission spectrum? The spectrum in which the line represents a specific wavelength and wavelength of radiation which is emitted by an atom is referred as a line spectrum. It referred as in lines. Okay, we have studied continuous spectrum, atomic spectrum and emission spectrum or line spectrum. Next we are going to study about atomic absorption spectrum. If you talk atomic absorption spectrum, when white light is passed, means we are taking a light is passed in cool vapors, the element or certain wavelength may be absorbed by the wave found in transmitted. Okay, means the vapors are passed to a prism. It is a photographical plate. It shows a different line. Atomic absorption spectrum or absorption spectrum. We'll write when white light is nothing but all visible wavelength. We know that all visible wavelength is nothing but we can visibly see its radiations. Its radiations nothing but approximately comes in visible regions 400 nanometers to 700 nanometers. It's perfectly visible region. All visible wavelength is when white light is passed through, means white light is nothing but all visible regions. When white light is passed through cool vapors of an of an element certain wavelength may be observed thus observed wavelength are not found in transmitted light. Means wavelength are not found in transmitted light. The spectrum contains dark lines, which shows means a dark lines. Already I explained in hydrogen spectrums. The spectrum contains dark lines is called atomic absorption spectrum. It called as AAS. Atomic absorption spectrum or absorption spectrum is called AAS. Okay, next we are going to study about atomic spectrum of hydrogen. Next we are going to study about atomic spectrum of hydrogen. You see, the atomic spectrum of hydrogen was introduced by J.J. Balmer in 1884. What he done? He taken a discharge tube. I think I explained already in first class only. Discharge tube, discovery of cathodes. He taken a discharge tube. In discharge tube, the electrons are moving towards the cathode to anode. The slit I have applied here. Two slits are applied. This is discharge tube. In discharge tube, the electrons are passing. The two slits are placed, and we keep the lens. It may be concave or convex. Okay. Discharge tube, and the slits we have kept in middle between the lens and discharge tube. The lens passed through the prism. Lens is passed through the prism. The prism, it deviates to form four prominent colors. This is nothing but photographical plate. The first you observe the four prominent colors. That four prominent colors is a violet, blue, bluish green. Another one is blue. Blue, violet, blue, and bluish green. Another last is red. We know the violet will absorb in 4102 angstrom. When come to blue, it will see in 4340 angstrom. Bluish green 4861 angstrom. The red is absorbed 6563 angstrom. This all the wavelength is absorbed. The four prominent colors using a discharge tube. Okay, using a low and high pressures. This four, he told that Balmer series. It's told that Balmer series. The atomic spectrum of hydrogen, it took a discharge tube and kept a discharge tube, kept two slits and lens. It passed through a prism. This is a prism. The four prominent colors is observed in the photographical plate, that is violet, blue, bluish green, red. The violet wavelength is 4102 Armstrong, the blue 4340 Armstrong, bluish green 4861 Armstrong, the red 6563 Armstrong. These four is called as a Balmer series. You see what we observed today, the spectrums. Four spectrums. First we talk on that electromagnetic, spectrum. In the electromagnetic we see this gamma, X-ray, UV, gamma rays, next X-rays and UV and visible and infrared and radio rays. We are increasing the wavelength, decreases the frequency. Okay, increasing the wavelength, decreases in the frequency. We studied in electromagnetic spectrum. In electromagnetic spectrum we studied the continuous spectrum. In the continuous spectrum, what we told, the continuous spectrum, the white light is passed through a prism, stately prism. It shows the Vibgaya series. White light pass. It shows Vibgaya. It comes in 4000 Armstrong to 6500 Armstrong. It is called a continuous spectrum. Continuously is passing the series of bands. The violet is a short wavelength, high frequency. Red is longer wavelength, shorter frequency. Correct, no? Next we have studied about atomic spectrum. In atomic spectrum we told that the ranges of characteristics of frequency of electromagnetic radiations are readily observed, means atom will observed and emitted by an atom. We told that it will be observed the atom and also emitted the atom by electromagnetic radiations by range of frequencies, based on frequencies. Next we have studied about atomic emission spectrum. In atomic emission spectrum or line spectrum, we observed all the emitted atoms in wavelength of radiations by the line. For example, we take a sodium, we keep a Bunsen burner, the sodium, the radiation is passed to a photographical plate, then we see that it is in a line. Next we have studied about atomic adsorption spectrum. In this, what we observe, the white light is passed through a cool vapors, means cool vapors, the element certain wavelength may be observed. See, the elements may be observed, thus observed wavelength not found in the transmitted, means maybe some frequencies does not observed here. That is nothing but spectrum contains a dark, means it shows a dark, it never shows a single line, it shows a dark. That is absorption spectrum, means absorbing. Okay, here emitting. Okay, is nothing but adsorption spectrum. Next, last we are studying about atomic spectrum of hydrogen. This what we taken a discharge tube, pass through a slit, discharge tube pass through two slits, we keep in a lens, pass to a prism, we observe the four colors, that is nothing but violet, blue, bluish green, and also red. It's called as a Balmer series. Okay, this we observe by the electromagnetic spectrums. So that is continuous spectrum, atomic emission spectrum, or line spectrum, or atomic absorption spectrum, or last atomic spectrum of hydrogen. Next we are going to study about Bohr's explanation of Bohr's explanation of hydrogen spectrum. By the spectrum only we told that the atoms, in atom, the electrons will be absorbed and emitted. The emitting, you see, we are going to write that intensity by wavelength. You see, we take some series. N is equals, means we are taking first orbital, n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4, n is equals to 5, n is equals to 6, n is equals to 7, n is equals to 8. When atoms are observed and emitting, means atoms are observed from orbital 2 to 1 orbitals, from, you see, this will be written, the atoms are absorbing, correct, no, and emitting. Means first we talk that atoms are observed and emitting from orbital 2 to orbital 1 and orbital 3 to orbital 1, means it's not observed and emitting. Okay, emitting means it's emitting from 2 to 1, 2 to 1. Okay, we are talking that absorption. 4, another one is 5. Means atoms are observing from orbital 5 to orbital 1. It is Raman series. Similarly, next we are going to talk about when atoms from emitting from 3 to 2 and 4 to 2, 5 to 2, 6 to 2. This series is nothing but Balmer. Okay. Next we are talking about, we have taken that n is equals to is over. Next n is equals to 3. When come n is equals to 4 to n is equals to 3, means I am talking that electrons are coming from n is equals to 4 to n is equals to 3. Okay, maybe my diagram is not good. Okay, it is Pascal series. It is Raman series, Balmer series, Pascal series. Okay, next we are going to talk about when electrons come from n5 to n24, it is called bracket series. Okay, we want to extend the lines. What it tell last, taken that n is equals to 6 to n is equals to 5, it is p fund series. You see, all the Pascal and bracket and p fund series will be seen in infrared. We'll see in infrared series. Okay, what? Pascal, bracket, p fund will see in infrared. When we talk about visible, we see in bracket. Balmer series will see in visible region. When come to Raman will see in UV. Means it's a nucleus. It is n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4. When electrons coming from 2 to 1, it is absorbed. Correct? No? It is Raman series. Similarly, 4, it is coming. We are not talking about emission. We are talking absorbing. Means n2 n1, n3 n1, n4 n1 is coming. It is nothing but a Raman series. Do you understand this? Raman. Similarly, the Balmer, Pascal, bracket, p funds. But these three will be observed in infrared. Balmer will observe in visible. Raman series observed in UV rays. Okay. Next, we talk about the series. What the series will be observed. We will write in some tabular column. First, we take the series. Another one n1, another we talk n2. Means where will come? It is initial, it is final. Where will be come? The region. Which region will be come? Another one is its wavelength in the Armstrong. Wavelength under the Armstrong. Okay. Series. First we series we talk about Raman series. Okay, Raman series. Raman series, we talk n is equals to 1. Correct? No? While seeing the diagram, n is equals to 1. Initial. Correct? No? Initial is n is equals to 1. Initial n2 is nothing but starting from 2, 3, 4. So 2, 3, 4, 5. Correct? No? Talking 2, so 3, 4, 5. Which region I told? It is in UV region. UV region in Armstrong we talk about 9200 to 1200 Armstrongs. 1200 Armstrongs. Okay. Next we are talking about it's for the Raman series. Next we are going to talk about Balmer we talk the initial what? n is equals to 2, correct? No, n is equals to 2. N is equals to 2. We start n2 is nothing but 3, 4, 5, 6. It's seen in visible. Seen from visible. It range is 4000 Armstrong to 6000 Armstrong. Okay. Next series we coming to passion. Passion. N is equals to 3. N2 is nothing but 4, 5, 6, 7. It is seen in infrared. Infrared. 9500 Armstrong to 18,750 Armstrong. Not 1 lakh, 18,700 Armstrongs. I want to write Armstrongs, forgotten it. Next, we are going to write about bracket. Bracket series n is equals to 4, 5, 6, 7. Okay. It shows similarly it is infrared radiations. The wavelength is 19,450 Armstrong to 40,500 Armstrong. I am talking in Armstrong. Last series, that is P fund series. N1 is nothing but 5, N2 is nothing but 6, 7, 8. It is region is infrared regions. Its wavelength is 37,800 to 75,000 Armstrong. This will be observed by seeing this diagram. It is nothing but Bohr's explanation of hydrogen spectrum. Next class we are going to study about Bohr's model of atom.